Okay, guys, so this is the second part of the discussion on friction. Okay, so let's go back again on the definition of friction. Okay, so again, friction F is the force that resists sliding motion, and it acts parallel to the contact force, the surface of contact between the two objects. There are two conditions in order to have friction between two objects. First is that the objects must be in contact. Next one is that the objects must be sliding along the surface of contact, or at least there must be an external force that is trying to slide the object. Okay, so friction depends on two factors. The normal force perpendicular to the surfaces in contact. Of course, the normal force also depends on the weight, so it follows the greater the weight of an object, the greater the normal force that supports the weight of that object, and therefore, the greater the friction that exists between the two surfaces in contact. In contact. The nature of surfaces in contact. Another factor in determining the amount of friction that exists between the two surfaces in contact is the nature of surfaces in contact, which includes several factors such as in the interaction of molecules and roughness of the surface. So what does the first factor mean? We know, as we have discussed previously in the first video lecture, that the normal force is the support force that supports the weight of an object. Whenever that the direction of the normal force and the weight are directly opposing each other, such as in our example, the weight of the block being supported by the support force or the normal force provided by the table. One factor in increasing the amount of friction that exists between the two surfaces in contact is the weight of the object. Of course, this means that when you increase the weight of the object, the tendency of a greater weight is that the greater weight presses more on the surface of contact between the two objects. So the increase in pressure due to the increase of weight causes the object that supports the weight to increase its support force. So for example, in our block and table example, if you're going to replace the block with a greater with another block with greater weight, twice the weight for example, so the greater weight causes a greater pressing on the surface of the table, and the natural effect of the table is to counteract this increase in weight by increasing the support force provided by the table uh, on the new block or the block that has greater weight. So this means that a greater weight produces a greater support force, and it's therefore producing greater friction that exists between the surfaces of the block and the table. So in summary, the greater the weight, the greater the normal force, and the greater the friction. Okay, so another factor that contributes to whether the friction that exists between the surfaces of objects increases or decreases. Uh, One factor is it depends on the nature of the surfaces of contact, in contact. So, for example, between cement and wood, you would have a certain amount of friction, but you have a different set of friction between cement and rubber. Between cement and rubber, the friction that exists between cement and rubber has greater value as compared to, for example, ice on cement, or wood on ice, or wood on cement. So all of this has different values, which dictates, simply says that um, the nature or amount of friction that exists between the surfaces depends on the type or the nature of the surfaces in contact. Another factor is the roughness of the surface. Of course, uh, the 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 greater the roughness of the surface in contact, the greater the friction. The smoother the surface in contact, the lesser the friction that exists between the two surfaces. Now, there are two types of friction. We have static friction. Static friction is the type of friction that exists between two surfaces that are at rest relative to each other. While kinetic friction is the type of friction that exists between two objects that are moving relative to each other. So, for example, in our block and table, the type of friction that exists between the block and the table is static friction, while in a moving car, the friction that exists between the rubber surface of the tires of the car and the cement of the pavement is actually kinetic friction. Now, friction exists between surfaces regardless whether the objects are moving relative to each other or not. As I have mentioned a while ago, static friction exists between two objects that are in contact with each other, but there is no relative motion in between. So, for example, in our illustration here, you have a block on a surface of a plane. If you're going to incline the plane in a diagonal sense, for example, towards this direction, there is a certain angle wherein the block would not actually slide down the plane. Therefore, there exists a frictional force between the surfaces of the block and the plane, which prevents it from sliding down the plane. And this force is static friction. Now, once if you continually increase the angle of the inclination of the plane, there would come a situation wherein the block would actually slide over the surface of the plane, going downwards to the direction of the plane. And this happens when the weight of the object actually overcomes the static friction that exists between the surface of the plane and the block. Okay, so as stated here in this illustration, as outside forces F increases static friction, F sub static friction also increases such that the outside force equals the static friction. So what is meant by this illustration is if you want to start the motion of the block, for example, toward if you want to push the block towards this direction, what you need to do is to apply a horizontal force towards this direction. Now, of course, by the presence of the frictional forces in of the surfaces in contact, this force would be opposed by the static friction that exists between the block and the surface of the from which the object is resting on. If the amount of force does not overcome or simply equals the amount of static friction that exists between the surfaces, then what happens to our block is that the block will not actually move towards the direction you want it to move. So the idea here is if you want to move the object, you need to overcome the effects of static friction. Now, in order to overcome, that means the application of the force should be greater as compared to the amount of static friction that exists between the surfaces. Now, what happens is once that the amount of force overcomes this friction, it doesn't necessarily mean that the static friction becomes zero, but it actually exists in the form of kinetic friction. There is still friction that exists between the two surfaces, but it's actually lesser as compared to the amount of static friction. So what happens in a continuous scenario? What we want is to push the block towards this given direction, and what we need to do is to overcome the amount of static friction. Once we have overcome that, the static friction is no longer static but is kinetic, and the amount of kinetic friction is actually lesser as compared to the amount of static friction. Now, the existence of the kinetic friction is actually the one who is causing the object to slow down. If this force is the one who is causing the object to move towards this direction, this is also the force that possibly could accelerate the object in an increasing amount of speed. Now, since the frictional force is the one who is opposing the direction of the force of the movement, basically that translates into the amount of force which causes the object to decelerate. Now, at this point, we will be discussing the idea of a free body diagram, or free body diagrams. A free body diagram is a graphical representation of forces acting on an object. Previously, we have defined several of these forces. We have defined already the forces of normal forces, frictional forces, tension, and the weight. And in a general sense, a force could be a push or a pull. Now, if you're going to draw a free body diagram, what you're going to do is simply to draw all the forces that are acting on an object, a single object. So for us illustrated here, the you have a person that is pushing against an object, such as a refrigerator, for example. So if you're going to identify what are the forces that are acting on our object, it would be the following. Of course, we have the weight of the object, which is acting downwards. We have also the support force provided by the surface on which the object is resting on, countering the effects of the weight. We also have the pushing force of the person, which is directed towards this direction, and also the frictional force that opposes this pushing force. Now, if once we have identified all the forces acting on our object, we can draw it in our Cartesian plane. And our Cartesian plane, we call this Cartesian plane a free body diagram. Okay, so at this point, we now discuss Newton's second law of motion, or we call the second law of motion the law of acceleration. So what this is the statement of the law of acceleration. A net force causes acceleration of an object, and this acceleration is directly proportional to the net force and inversely proportional to the mass of the object. In the basic formula or form of Newton's second law is uh, F is equal to mass times acceleration, where F is actually the net force or the vector sum of all forces acting on an object. We call this sum of forces as the net force. M is the mass of the object, and A is the acceleration produced by the net force.